right, the log parent function to get us started is f of x equals log of x. And so our parent function is log base 10 of x. And that's the button in our calculator next to the number 7. That's the log base 10 button. So we're just going to look at a picture. If on your calculator, you'll go into your y equals menu, and I want you to just type in log of x and close your parentheses. That's log base 10 of x. And we're going to look at a graph of the parent function. And our calculator struggles to show us asymptotes when they're vertical. But right here, there's a vertical asymptote that goes down along the x-axis. And so we're going to sketch this. It comes from down here. It kind of hovers right along the x-axis. It goes through at 1. And then it continues to go up and out. One important feature of log functions is that they're the inverse of exponential functions. So I'm also going to graph the exponential function 10 to the x, so base 10, base 10. And I'm going to put it on the graph. And notice that this one, we've done these ones, comes in along the y-axis, goes through at 1, and then gets exponentially bigger as it goes farther out. Things that we know about inverses. Inverses reflect each other across that diagonal line. So these two functions have a diagonal reflection where all of their xy points would be inverted if they're the same base. Okay, they're inverses of each other. Things that are also inverse about them. The log function has a vertical asymptote that starts at x equals 0. And the exponential function has a horizontal asymptote at y equals 0. Our domain and our range are inverses of each other. Our x's and our y's are inverses of each other. Our y-intercept and our x-intercept are inverses of each other. This is 0, 1. This is 1, 0. So everything about a log function and an exponential function that have the same base is an inverse of the other. So now, in our calculator, we're going to be working on graphing logs today, but we're going to graph log base 2, log base 1/3, and we are only using this log button right here, which only does log base 10. So we can't actually type log base 2 of x into our calculator. We have to use a different strategy. And what we're going to do is we're going to find the inverse equation. Okay, so we're going to flop the x and the y, find the inverse equation and graph it, or make a table of points. Then we're going to invert those points. Okay, so there's kind of a roundabout way that we graph these log functions. So I'm going to start with this equation right here. And I want it to have a y instead of an f of x. So my first step is just to rewrite it with the y on the other end. Okay, I haven't changed anything. I just rewrote the equation. Okay, now I'm going to roll it into an exponential equation. So it's going to become 2 to the y equals x. These two things are the exact same. They're not inverses of each other. They're exactly the same, just rewritten in a different way. But here's the problem. We can't put a table of y values in our calculator. We can only put in an equation with x in our calculator. So now we find the inverse. Inverse means we switch our x and our y. And this equation right here is the inverse of this equation up here. Okay, these are opposites. They'll reflect each other. They'll have opposite asymptotes, opposite intercepts, opposite transformations. This we can put in our calculator, y equals 2 to the x. In your calculator, I want you to type in y equals 2 to the x and pull up your table of points. Now we need a few points to show us where the asymptote is going. So I know here, like I have 1, and then I have a half, a fourth, an eighth, a 16th. So I know that my graph is approaching 0 because these fractions are going to go to 0. And then I want a couple that show me where the exponent grows. So on this, I'm going to do -2 through 3. I'm making a table right here, x, 2 to the power of x. Okay, so I'm going to have -2 with 1/4, and I'm just copying these straight out of my calculator. -1, 1/2. This is showing me where my asymptote is. 0 with 1, 1 with 2, 2 with 4, and 3 with 8. Okay, and just so we recognize what we're doing here, 2 to the power of -2 is 1 over 2 squared, 1/4. 2 to the power of -1 is 1/2. 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 squared is 4. 2 cubed is 8. Okay, but this is not my function. This is the inverse function. So now I'm going to use this to generate the points for my actual function. It's going to have all the same points. They're just flipped. So x, y, 1/4 with -2, 1/2 with -1, 1 with 0, 2 with 1, 4 with 2, and 8 with 3. Okay, I'm done with this. I needed this math to generate a table of points because mental mathing logs is hard, but we can do exponents pretty easily, or we can use our calculator, right? These are the points that go on my graph. This is forward 1/4 down 2, so I have a point really close to the y-axis. This is right 1/2 down 1, 1, 0. It's my x-intercept. 2, 1, over 4 up 2, over 8 up 3. And we'll draw our curve. Okay, now I'm just going to pull this out of my notebook because I think I have a 2 to the x graph right here, okay, from this we did the other day. And my log base 2 to the x, 2 of x. Okay, so log base 2 of x and 2 to the x inverses of each other. And so they go opposite ways. So here's what changes. Look at the domain and range on my exponential equation. All real numbers. Y is greater than 0. It's the opposite here. My range goes down, goes up, all real numbers. But my domain is restricted because I have a vertical asymptote. So we're going to say x such that x is greater than 0. Or you might say 0 to infinity. Okay, Next we analyzed our end behavior. Remember, our exponential had one end that went up to infinity, and it had an end that went flat, looking at our y values, okay? Both of my y values actually go to positive and negative infinity here. My right end is going up, but on my left end, it's x that is approaching the asymptote of 0. Okay, so those are flipped. I don't have a y-intercept. I have an x-intercept instead, and it's at 1, 0, and it'll be usually a point in the table. And my asymptote is, instead of y equals, this is a vertical line, so it's x equals 0. Okay, let's try another one. Question number 2 says f of x equals log base 1/3 of
Ben Enoch
x.
and his friends back to Hawbaker's room. Ben Enoch and his friends back to Hawbaker's room. Thank you.
And just for a point of reference, if this were an exponential function, it'd be a decay function. So here we're going to find the inverse of a decay function, or our inverse is going to be a decay function. So I'm going to first rewrite it. Log base 1/3 of x equals y. And the only reason I do this is because it's easier to see where I should roll it if I write it in this order. So now I'm going to rewrite it as 1/3 to the y equals x. And now I'm going to invert it. 1/3 to the x equals y, because this I can put in my calculator to find a table of points. You could also mental math this to create your table, or you can do one point at a time. I could do 1/3 to the -2, 1/3 to the -1, 1/3 to the 0. That's what we were doing previously, but you're welcome to use the table in your calculator. So -2 with 9, -1 with 3, 0 with, oh, I typed that in wrong. With 1, +1 with 1/3, +2 with 1/9. Okay, this is not our function. This is the inverse of our function. We're not going to graph those points. We're just going to use them to create the table that we're looking for. So now I'm going to make a table xy, and I'm going to invert each point. So 9, -2, 3, -1, 1, 0, 1/3, 1, 1/9, 2. And we'll put them on our graph. So I'm going to go forward 9, down 2, forward 3, down 1, x-intercept at 1, 0, 1/3 and up 1, 1/9 and up 2. So I see my fractions getting really close to the axis here. And then going down and away. All right, so I'm going to identify my asymptote. It's right here on the axis at x equals 0. And that's going to affect my domain and one of my end behaviors. So domain x such that x is everything greater than 0. Or 0 to infinity for my x values. Domain or range is all real numbers. Okay, it goes up, it goes down. Okay, so here I I have to look for my end that goes up and decide if it's going to 0 or if it's going out to infinity. Okay, my end that goes up is here, and it's the side on the asymptote, so that's where x is approaching 0. This one means down. My end that's pointing down is going to go out and away forever. Infinity. Okay, so those will be switched depending on if you have growth or decay in your inverse. And then my x-intercept is the point 1, 0. Ask me a question. What can I clarify? Turn the page when you're ready. Okay, now we're going to do some that have transformations. So these are a little trickier to work through the inverse portion of it. We're still going to start the same. And if we think about this, what kind of transformation do you suppose this would cause? If I have a -1 inside with my x, what's that going to do to my graph? It's going to, I heard it. It's going to shift it left or right, up or down?
Left.
Right, x is always opposite. Okay, so this is a standard function shift to the right by 1. Now we're going to see in a minute when we identify our inverse, it's going to have the opposite transformation. Okay, we're going to write this as log base 4 of x minus 1 equals y. In order to roll it, because we're working with some transformations here, you have to have your log alone on one side before you can roll it. We do. We're good. The next one's going to change just a little bit. We're going to roll it. 4 to the y equals x minus 1. And now I'm going to swap my x and y. 4 to the x equals y minus 1. I can only put this in my calculator if the y is by itself. 4 to the x plus 1 equals y. So now I have a transformation. It was right 1, but now it's up 1. So a horizontal's inverse is a vertical. Okay, we're going to find a table of points for this. And you're welcome to mental math it or use your calculator. Okay, and I know, based on what I know about exponential equations, this moves that asymptote, and so I should expect to see my fractions bottom out at 1, and then I've got big enough numbers here that it's going to go off the graph, but this is not my function. I'm going to invert these points so I can graph it. So 1.1 with -2. 1.2 with -1, 2 with 0, and there's my x-intercept shifted to the right by 1, 5, 1, and 17 with 2. Okay, 1.1. 3, 4, 5, 1. When you take your quiz tomorrow, I don't care if you draw in the asymptote or not, like it's not required, but I find it helpful. So here's my asymptote at x equals 1. which makes sense because we said we're shifting it right 1. This is shifted right 1. That's going to affect my domain. X has to be greater than 1. Range is still all real numbers. Okay, now my end that's going up is pointing out forever. Those X values are going to get bigger and bigger and bigger. But my end that's going down, f of x to negative infinity is down. That's the side that's on the asymptote. So I'm going to match its number to the asymptote. And then my x-intercept comes out of my table. It's the point 20. If your x-intercept doesn't show up in your graph, or doesn't show up in your table, put a 0 in right here and solve it, and flip those points. All right, this next one's going to have an extra step to it because I have this -2 at the end. It's not in parentheses with the x. Okay, that means it's a vertical transformation. It's shifted down 2. So we can expect our inverse to be shifted left 2. But here's how we invert this one. I'm going to say log base 3 of x minus 2 equals y. I'm going to add 2 to the other side so that I have log base 3 of x by itself. And now I'm going to roll it. So I have 3 to the y plus 2 equals x. Okay, and that step is what determines if your plus 2 ends up in the exponent or ends up down below. So you have to watch for that. And now I'll inverse it. 3 to the x plus 2 equals y. Okay, and here we notice this was down. This one goes left because it's grouped in there with x. Those are inverses of each other. Make a table of points. And if this goes left 2, I want to start in my table at -4. Okay, 1/9, 1/3, 1. I'm putting fractions because I got my count off. 4, 3, 2, -1. Because my brain graphs fractions better, but if you put decimals in here, I'm okay with decimals. -2, 1, -1 with 3, 0 with 9. Okay, now we'll flip our points so that we have the values for our actual function. Okay, and graph. Okay, and we said that this one would be shifted down 2, and it's hard to recognize down 2 by looking, but if you think of where we usually have an x-intercept right here, and we don't, my line is below that. I don't have my x-intercept till way further out. That kind of helps us see the down 2 part. Okay, so we've got an asymptote still at 0 because we don't have a left or a right shift. X equals 0. and that's going to affect my domain. My range is still going to be all real numbers. The end of my graph that goes up, that's this end, it's going out. The end of my graph that goes down is touching the asymptote. So its x value matches the asymptote. And then my x-intercept is right here at 9, 0. You ready to try one on your own? Okay, you have to get, so the 4 is away, the 4 has to move before you can roll it. Okay, and I'll work through it while you work through it, but do what you can on your own and look up or ask a question when you need guidance. Oof, I am way off. I need white out.
Any student getting vaccine and have a completed form can go to the commons area. Only if you have a completed form.
Okay, I've got my whole answer up there so you can check your work. It was a lot of steps to get through that inverse. Ask me a question if I can help. Try number 6 if you're ready for it.